What's up, all you Sioux High AP biology students? This is Mr. McLeod again. Welcome to part 2 of our next podcast on phylogenetics in the tree of life. Today we're going to continue our discussion of cladogram basics. So let's look at node A. So let's find node A. Here's node A right here with a circle. In this diagram, node A is termed the root of the cladogram because it's at the base or the beginning of the cladogram. In this case, the root is normally drawn with a dangling branch. So let me get the draw tool here. Here's the dangling branch right here. So the root is normally drawn with some kind of a dangling branch. So this indicates that this clade is also a part of a more inclusive clades of living organisms originating from even earlier ancestral populations. I think we explained that when we started. So this indicates that there's more ancestors earlier back in here. Eventually, this dangling connection would lead clear back to the ancestor of all life, whatever that is. We know what we think it is now scientifically, but certainly that's not a given. You can think about this cladogram as the hypothesis / prediction of what branching events happened since the moment in time when the ancestral population at node A first became a species. Write that down, and then we'll talk about what that means. So you can think about this cladogram as the hypothesis or prediction of what branching events happened since the moment of time when the ancestral population at node A first became a species. What this means is is that when it split from one into two species. So when it split from one into two species, and then here you can see this ancestral line now becomes even more evolutionary important. Later in time, there were further splits resulting in new clades you can see here in this cladogram. The clade arising from the ancestral population at node B, right here, originated later than the one arising from the original ancestral population at node A. That's very important that you understand that. So B after A. The clade arising from the ancestral population at node B is termed to be, here's a new term, brace yourself, hierarchically nested within the clade arising from node A. You're going to see that terminology on the test, so make sure you get it in your notes now. It means that B is hierarchically nested within the clade arising from node A. So get that in your notes. Let's use an example. Mammals, for example, are nested hierarchically within the clade of all vertebrate animals. Get that in your notes. Now, the common ancestor of all vertebrates lived before the common ancestor for all mammals. There are vertebrates that aren't mammals, but all mammals are vertebrates. So mammals are a particular subgroup or part, or hierarchically nested within the whole vertebrate clade. Also write that down as an example. Now, there are 4 terminal nodes in this example. Remember that the terminal nodes are over here. These include members of the in-group, see this little bracket here, the in-group in other words, taxon 1, taxon 2, and taxon 3, in a single outgroup taxon right here. So make sure you understand that. 4 terminal nodes. Now, many phylogenies also include what's called this outgroup. And let's define what an outgroup is. A taxon outside the group of interest would be considered an outgroup. Write that down. A taxon outside the group of interest, this in-group, is considered an outgroup. All members of the group of interest are more closely related to each other than they are to the outgroup. I hope that makes sense to you. So these 3 are sisters, right? Well, this outgroup is not part of that family. So these are more closely related than the outgroup is. Make sure you get that down. Hence, the outgroup stems from the base of the tree, right here. And an outgroup can give you a sense of where on the bigger tree of life the main group of organisms fall. Write that down. And it's also useful when constructing evolutionary trees, which we'll get to later in this podcast. Okay, the clade arising from node B. So here's node B. Node B, right there, includes all 3 in-group taxa. Pardon me. The purpose of a cladogram is to express a particular hypothesis for the relative branching order of the in-group taxa. This cladogram example suggests that taxon 2 and taxon 3, right here, more recently shared a common ancestor than either does with taxon 1. Get that in your notes. So because these are closer to each other, that means something. Well, this hypothesis implies that the ancestral population at node B lived before the ancestral population at node C. It does not say how much earlier it lived. In other words, the cladogram is only a hypothesis of the relative order of branching. It doesn't indicate how much absolute time passed between the branching events. So we don't know, for example, how long this is. We just know that taxon 2 and taxon 3 came after taxon 1, but we don't know how long. So a cladogram is not designed to give you exact times. It's designed to show relative times. So make sure you get that in your notes as well. Now we should be able to find a clade originating from each internal node, right here, a clade originating from each internal node in this cladogram example. Now, a helpful way to think about which groupings of terminal nodes are clades, which is absolutely one of the skills you need to know, is the Snip Rule. So let's write down the Snip Rule in your notes. Now, whenever you snip a branch directly beneath an internal node, a clade falls off. Write that down, and then we'll give an example. So whenever you snip a branch directly beneath an internal node, a clade falls off. Now, let's look at, there are the 3 clades in this diagram. So, the first clade is taxon 2 and taxon 3. So if we snipped right here below B, taxon 2 and taxon 3 would fall off. So they're a clade. All right, the next clade is taxon 1 plus taxon 2 and taxon 3. So if we snipped right here below A, taxon 1, 2, and 3 would fall off. So they're also a clade. And then if we snipped right here above A, the outgroup, taxon 1, taxon 2, and taxon 3 would fall off, so they're also a clade. Now in contrast, a grouping of taxon 1 and 2 without taxon 3 is not a clade. So there's no way to snip so that 1 and 2 would only come off by themselves. So if you snipped here, taxon 3 falls off. So 1 and 2 are not considered a clade. So make sure you get that in your notes, the Snip Rule, and then make sure you understand the Snip Rule. So again, we couldn't make a clade, for example, out of the outgroup and taxon 1 because there's no way to snip for them to fall off by themselves. Okay, hopefully you get that, so let's move on. Okay, now let's look at an example of a cladogram, a real one, and see if we can make some sense of it. Now, if in this example, note that the terminal nodes snake and lizard are sister taxa. So let's get the drawing tool up here, and let's find the snake and lizard. So the snake and lizard are considered sister taxa. You get that, right? Because they're so close to each other, they're considered sister taxa. The branches leading to them meet at node 1. So here's node 1 right here. Now, they meet at node 1 to form a clade, this red bracket right here. So if we snipped right here, snake and lizard would fall off. Or if we snipped right here, snake and lizard would fall off, so they're a clade. Likewise, bird and crocodile are sister taxa. So here are bird and crocodile right here. They are members of clade B, who share a common ancestor at node 2. So snake and lizard share a common ancestor at node 1. Bird and crocodile share a common ancestor at node 2. Note also that clade A and B are sister taxa. So these two would be considered sister taxa, clade A and clade B. One way to think about this is to consider the Snip Rule for dividing clade C into the daughter lineages derived from a common ancestor at node 3. So here's 3 right here. Imagine traveling up each branch from node 3 only a short distance before snipping. What falls off are the sister taxa, clade A and clade B. So here's clade A and clade B. If we go back and snip here, all right, A and B fall off, so they're its own clade. Hopefully that makes sense to you. All right, let's move on.